Today we've got a differential equations question. It comes at the very end of a paper, so you know we should be in for a challenge. In part A, we are asked to express 1 over p times by 11 minus 2p in partial fractions. So to understand partial fractions, you need to know that it's equal to one fraction with the first bit of the denominator and another fraction with the second bit of the denominator. And a and b are constants that we have to work out. And to find what a and b are, we times both sides by this denominator. If we times the left-hand side by this denominator, we get just 1. If we times this by this denominator, the p's will cancel, and we'll be left with 11 minus 2p. Similarly, if we times b, the 11 minus 2p's will cancel, and we'll be left with just bp. What we can do now is we can choose specific values of p such that we can find a and b quite easily. I'm going to let p equal 0. This means that 1 will be equal to a times by 11 minus 0 plus b times by 0. Straight away, this tells us that a is equal to 1 divided by 11. I'm now going to let p equal 11 over 2, 5.5. That means that 1 will be equal to a times by nothing, it will cancel out, plus 11 over 2b. That means that b, if we rearrange it, times by 2 and divide by 11, b is equal to 2 over 11. The reason that I use these two values is because straight away it cancelled out the a and the b, and it gave us the other letter. The values to think about are always when the denominators are equal to 0, and that should give you these good values, these key values to try. So let's just finish off the question then. We've not actually expressed it in partial fractions yet, so what I'd write is 1 over 11 and then p plus 2 over 11 and then 11 minus 2p. Alternatively, you can bring down the 11 like this, and this would be our final answer for 3 marks here. Now for part B. So we're told that we've got a population of meerkats that's being studied, and their population is modelled by this funky differential equation. We're given some boundary conditions for t and p, and we're told what p is, and we're told what t is. T is the time, usually is. We're also told that at the start of this study there are 1,000 meerkats, so that's just telling us some important value at some important time. That will help us work out the c in the integration that we do later on. What we actually have to do is to find the time taken for the population of meerkats to double. To solve a differential equation, we want to get everything that's p related onto one side and everything that's t related onto the other, and that includes dp and dt. So what I'm going to do in this case is I'm going to divide everything by p 11 minus 2p, and I'm going to times everything by dt. And we're going to get this. So the dt has moved to this side, and the p 11 minus 2p has moved to this side. Next, I'm going to use part A. In part A, we found the partial fractions, so it would seem a bit silly not to use them. And what we're going to get is 1 over 11p, and it was plus 2 over 11 minus 2p. Oh, that's supposed to be a dp. Put that in brackets, and it should be equal to 1 over 22 dt. And the last thing I'm going to do before I actually integrate it, you might notice 11, 11, and a multiple of 11. So I'm going to cancel the 11 to give it 2. So we'll get left with a half dt. And now I can add my squiggle of integration to both sides and get integrating. The integral of 1 over p is lnp. That's one of our classic ones that we need to know. I could put modulus around it, but if we read the question, it tells us that p is bigger than a 0, so there's no need. For this next one, you could use substitution, reverse chain rule. I'm going to use the fact that the integral of a derivative over the original function is ln of the original function. plus c. It's a really useful rule. It's not given in the Edexcel formula book, but it is given in the OCR formula book. And it just means that if we know what the derivative is, which we do, we can compare it to the top. What's the derivative of 11 minus 2p? Is minus 2. It doesn't say minus 2 on the top, but all we need to do is add in a negative and we're sorted. So ln p minus ln 11 minus 2p, and the integral of a half, hopefully you don't need too much help on this one for now, half t. You can add plus c onto the left, you can add plus c onto the right, doesn't matter, I just like to plop it at the end. Last thing I'm going to do is I'm just going to combine these two logarithms together, make it look a teeny bit nicer, like this. I wonder what c is equal to. Well, we're given a fact, we're given a condition down here that there are 1,000 meerkats at the start. What's the time at the start? Well, it's 0, hasn't started yet. So when t is equal to 0, p is equal to 1,000. Or is it? Go back up to the question. P is between 0 and 5.5. P is only equal to 1. Do you have to be careful with how you read this? If you put in 1,000, weird things would start to happen. So t is equal to 0 and p is equal to 1. That means that ln of 1 over 11 minus 2, 1 over 9, is equal to 1/2 of 0, which is 0, plus c. And then that tells us that c is equal to ln of 1 over 9, or, if you prefer, minus ln of 9. And therefore ln of p over 11 minus 2p plus ln 9 is equal to t. And I could also times everything inside the logarithm by 9. 9p over 11 minus 2p is equal to t. And now we're in a pretty good position. Determine the time taken for the population of meerkats to double. Well, if it's doubled from 1,000, it's now 2,000. So p is equal to 2,000, right? Still wrong. It's only 2. Again, we've got the conditions here. If p is equal to 2, then t is equal to natural logarithm of 18, 11 minus 4, so 7. One I can't do in my head. Just noticed I miscopied this. This should be a half here, which means that if we times both sides by 2, we get this, which means that t is actually 2 ln 18 over 7, which means that the actual amount of time is this, or let's round it to 3 significant figures like usual, 1.89 years. That part was worth 6 marks, but there's still 3 more to go. So let's talk about C. We now need to show that P is equal to that thing in terms of E. And this is actually not too bad. We're just rearranging here. We've got T here. So if we divide by 2, we get T over 2 is ln 9P over 11 minus 2P. And if we do e to the power of both sides, if we e it on both sides, we get e to the power of t over 2 is equal to 9p over 11 minus 2p. And given the question, it's got e to the power of minus a half. So it's of the right kind of form. We'll get them negative eventually, but for now, we'll leave it like this. What we can do next, we can multiply both sides by 11 minus 2p. So we're going to get 11 e to the t over 2 minus 2p e to the t over 2 is equal to 9p. We want p, so let's get all the p's on one side. 9p plus 2p e to the t over 2, and it'll be equal to 11 e to the t over 2. Again, we still want p, so if we factorize p out, we're going to get p lots of 9 plus 2e to the t over 2, like this. And if we really want p, we can divide by this bracket over here, which means that we will get p being equal to 11e to the t over 2 all over 9 plus 2e to the t over 2. It's not in the form given, but it's okay. How are we going to produce a power e to the minus? We're going to divide by this e. If we divide by e to the t over 2, it's going to disappear here, it's going to disappear here. We'll get e to the negative t over 2 over here. So divide by e to the t over 2, divide by e to the t over 2, and then divide by e to the t over 2. It's not quite in the right form, so I'm just going to spend one more step making it look exactly the same to really show that I have done what they want. And now we get a as being 11, b as being 2, and c as being 9 in the form that they want. And that is it for 12 marks in total. Well, there you have it, another question done. Hopefully you didn't make the same silly mistake as me. If you want more practice, you can try these 2 questions. Hopefully see you again soon.